If you can't adjust the current and voltage properly, how can you expect your welding wire to work well? Here's a 5-minute tutorial video for beginners. To get it right, you first need to understand what current and voltage are. Look at this button. It's the current control. The higher the current, the faster the welding wire feeds. The lower the current, the slower it feeds. That's the difference in current. The knob above is for voltage adjustment. Voltage represents the melting speed of the welding wire. Higher voltage means faster melting, and lower voltage means slower melting. Proper adjustment means getting the right amount of current and voltage. Proper matching is the first issue we need to understand. What are current and voltage? To adjust the current and voltage correctly, we need to listen, observe, and adjust. Every step is essential. First, whether we're adjusting the screen or the welding area, there's a prerequisite. We must first fix the current to adjust the hydraulic pressure. To fix the current, you need to determine the current based on the thickness and location of the material. For example, in the welding area I'm showing, the material thickness is about 8 millimeters. My welding current is generally between 150 to 200 kilovolts. Let's choose a middle value, around 160-170 kV. Okay, now let's fix the current at 170 kV. See how I adjust the voltage to the minimum and how I gradually increase it, showing the difference between increasing and decreasing. Now let's see. I fixed the current at 160 kV. So let's first adjust the voltage to the minimum. Remember, don't adjust it from high to low, as this can easily make the voltage too high and cause the water to smudge. We should increase the voltage gradually from low to high. This way it won't smudge. Next, let's adjust the voltage to the lowest setting. Let's listen to the sound as I adjust it. Oh, you see? This is because our voltage is too low. The water won't dissolve. Look at the entire water tank. It's just puddles of water, big puddles everywhere. This is because the voltage is too low. Now you see, I'll adjust the voltage to a much higher level. And this? So our voltage is too low. Now let's look at what happens when the voltage is too high. Listen to this sound, see? Puffing and puffing. And there's a lot of white smoke, right? Let's look again. After the voltage is too high, you see, your welding wire tip is severely bald. And there's a lot of smoke and dust on the wood. And the molten iron is in a large puddle. It's not flowing in a concentrated way, right? Let's look again, see? This is a manifestation of too high voltage. The welding wire tip forms a small round ball. Okay, so in that case, let's listen to the change in sound to start. Increase it again, increase it again. The sound has become very crisp. Molten iron. It's relatively flat, okay? But if you think it's ready to use now, looking at the molten pool means wearing a hummy type. If your weld pool is thinner in the middle and thicker at both ends, like a dragon or lion, and it will also form an undercut on the top side of the base material. If it feels too large, we adjust it smaller. Observing and adjusting. Let's look at the operational details and see if this old welding machine... Okay, the voltage is too low. Let's increase it. Hey, did you hear that? Okay. Let's take a look at this hummy type by listening to the sound in our first step. Looking at the molten pool. An oval-shaped weld pool is acceptable if it's rebuilt from its original shape. So, we've finished with the first step. After judging the shape of the weld pool, we adjust it larger. Next, to weld a high-strength weld pool for you can achieve a good result. Okay, increase it again. Now listen to the sound. That means our current and voltage are adjusted properly. This is how we judge whether it's suitable for us. You're very wrong. If your molten pool presents, now, this is a typical sign of insufficient voltage. That's also incorrect. There's one last step. 3 adjustments. This is our process of listening, which is over 10 years old. Let's adjust the voltage to the minimum and gradually increase it. It can't be drawn properly. Hey, there's no more crackling or popping sound, and the molten iron can completely melt. We still need our second step. Molten iron cap and observing the state of your molten iron melting. It's called a gourd shape or a figure 8 shape. This is a typical sign of excessive voltage. Listening, observing, and adjusting. If it feels too small, We'll use this old welding machine. After adjusting its center of gravity,